This is our video for the square root property, so I want you to label this on the next tab, square root property 5.12c, and then pause your video while you copy down this title section, and then come back when you're ready to do the problem. That was awkward. Okay, so what we're going to do here is a sample example where I write the problem on the left and explain it on the right. And then you're going to leave some room for 3 more problems after that. So here is the example. X squared minus 50 equals 0. So our goal before we square root is to get this equation to look like this form, where the constant is on the right. So the first thing that we're going to do is isolate the quadratic term. Isolate the quadratic term. So in this case, that means to add 50 to both sides. And that is going to give me the x squared term, the quadratic term, all by itself. So once that happens, now I can do square root both sides. So what I want you to write for step 2 is use the square root property. And that's what we wrote up at the top. So how that's going to look here is this. I square root both sides, and that means that x equals the plus or minus version of the square root of 50. And then the last step here is to simplify the radical. So that was when we would do a factor tree on the number inside the radical. So 50 is 2 times 25. And I'm actually going to stop at 25 because it's a perfect square. So I can stop right there and take the square root of it. You don't have to do that. You could do 2 times 5 times 5 and then simplify that pair of 5s, whichever you like to do. So right here, this simplifies to 5, and I'm going to bring that 5 in front of the radical. But I want you to pay attention to where the plus or minus goes when you bring that 5 out front. The plus or minus goes in front of the 5. It does not go here between the 5 and the radical. Do not put it in the middle. It goes out front. So using the that procedure, those steps, I want you to do this one by yourself. Y squared minus 27 equals 0. So pause the video and do that here. Okay, so here's the next example. Three z squared equals 108. Now on this one, the difference is we're trying to solve for the z squared, and before we had something either adding or subtracting to the variable, but here we have something being multiplied. But the goal is still to get that z squared alone. So how do we undo a times 3? We divide by 3. So 108 divided by 3, real quick math here. That gives me 36, so z squared equals 36. So now we do our square root property. We square root both sides. So z equals plus or minus the square root of 36. What do we like about 36 here? It's a perfect square. It's 6. So z equals plus or minus 6. So we won't always end up with a radical. Sometimes we'll have integers. Okay, And here's the last type of problem I want to do on this side. X squared plus 72 equals 0. So we're back to a plus or minus. So we're still going to do the opposite to both sides. So minus 72 minus 72. And then we're about to take the square root of both sides. What's up with this problem that makes it different from above? The negative. Now, in the past, if we take a square root of negative, we might say there's no real solution, but we just learned about imaginary solutions. So we're going to practice that skill here, right? So square root both sides gives me x equals plus or minus the square root of negative 72. And so here's how we handled that in our previous unit. We started by writing the negative as a -1. And now we have just positive 72 to factor. 2 goes into 72, we know because it's even, and it goes 36 times. And I'm actually going to stop right here because 36 is a perfect square. You can factor it more if you like, but I'm going to stop here. So the square root of 36 is 6. And what did we say is the square root of -1? I, and that comes out of the radical. Now I've pulled two things out. What do I do with those two things? Multiply. So the plus or minus goes in the very front. The 6i goes after that and next to the radical, and I have 2 left inside. So on the right side, we are leveling it up to where the x has something being added or subtracted inside. So again, on this side, I'm going to do a sample problem where I work it on the left and write the steps on the right. So try and give yourself a half and half space right here. And then we're doing 2 problems under that one. So here's the sample problem. 4 parentheses y minus 7 parentheses squared equals 48. The first thing we're going to do is divide by whatever's in the A spot, which in this case, when I say what's in the A spot, what does that mean to you? In this equation, what would you say? Yeah. And in this equation, it's a 4. So divide by the 4. Now, it really feels like we want to distribute here, but we are not going to because that group is squared. So we're not going to distribute into there. Instead, we're going to divide it off. So now I have y minus 7 quantity squared equals 12. Now that my squared term is isolated, I can do the square root property. To both sides. So when I square root the left side, it cancels out the squared, leaving me y minus 7. And then on the right, I have plus or minus the square root of 12. And then what I like to do next is simplify the radical. You probably noticed that there's that minus 7 on the left. We're going to take care of that last. So for simplifying the radical, we're going to factor the 12. What perfect square goes into 12? 4. So I'm going to factor this as 4 times 3. You could do 2 times 2 times 3 if you like. So the square root of 4 is 2. And that goes in front of the radical, but after the plus and minus. And the very last thing is solve for y. So that has a -7. I just need to add it to both sides. Now, because the 7 doesn't have a radical 3, I can't add it to the 2 radical 3. So I just have plus or minus 2 radical 3 plus 7. And I want you to pause the video and do this next problem on your own. 2 parenthesis b plus 2 parenthesis squared equals 80. So here is my work. Pause your video if you need a second to compare to yours and find any mistakes. And this is our last problem. 2 parenthesis x minus 2 parenthesis squared plus 3 equals 57. So our first goal is still to isolate the quadratic term. That's the group x minus 2. That's the thing being squared. So there's 2 things happening to that, a times 2 and a plus 3. We need to undo both of those. Which one do you feel like we're going to undo first? The 3. So we subtract 3 to both sides. And so now once I do that, I'm in the same form as I was in the previous 2 problems. There's a 2 out front. We're going to divide that to both sides. So now my group or my binomial is isolated. It's being squared. I square root both sides to cancel that out. So that leaves me x minus 2. And on the right, plus or minus radical 27. Please tell me a perfect square that goes into 27. 9. Yep. So I'm going to factor this as 9 times 3. You could factor this as 3 times 3 times 3. But square root of 9 is 3. That's a lot of 3's I just said. That comes in front of the radical, but behind the plus or minus. And then the very last thing is to add 2. So x equals plus or minus 3 rad 3 plus 2.